Hello. What I want to do with this talk is introduce some of the developer community to our new device, Passport Prime, and some of the cool stuff that you can do with it in the context of metaprotocols. So for some background on me, I'm Owen Kemeys. It's pronounced Kemis. It's Welsh. I'm definitely on Twitter too much. I made some threads explaining covenant stuff to normal people about a year ago that a lot of people saw. I can't keep myself out of these arguments, especially relay filter stuff recently. We all have vices. I write for Bitcoin magazine sometimes, again, trying to walk through like complex concepts if I can, try and make people think about things. And I read this red versus blue article that got a lot of traction last summer. I need to write a follow-up on this because we're about a year into that war. Let's see how it was going. But for work, I work at Foundation. We make Bitcoin-related hardware, most famously hardware wallets. I am not a programmer, though I have dabbled in things. So be patient with me with questions that are like really deep in the weeds on stuff. My background is actually mechanical engineering. So my brain works in mechanisms and systems and physical analogies. And that does actually translate surprisingly well to this world. And sometimes gives me a different perspective on stuff that's useful, but you can tell me. So just to frame out how this talk's going to go, we'll go over what a prime is and why it's a lot more interesting than your usual signing device. I have to lay some technical groundwork for you, like how things are laid out from the perspective of an app developer, and what our secure Bluetooth system looks like, because you'll probably want to use that. And then we'll get to the puzzles and the half-baked ideas that I had about building cool metaprotocol stuff for this, that I hope to get some gears turning in your head. So you've probably seen our current device, Passport, recently renamed Passport Core. That was first released in 2022. That is a Bitcoin-only hardware wallet with a fully air-gap design. It's a pretty straightforward, familiar concept. Data I/O is with QR codes, primarily using the camera or via an SD card. Users build their transactions on our mobile software wallet called Envoy, or any other QR-friendly software wallet that they like Sparrow, Nunchuck, whatever. We have an industry-standard secure element. We're really dedicated to open source, so even as a for-profit business, a lot of people don't realize even the hardware is open source, which to my knowledge nobody else does except for Seed Signer. So that means you can go and grab everything off of GitHub and start to manufacture these in your garage for profit if you wanted to. Our business gambit is that you won't do that, and even if you did, most people would still prefer to buy them from us rather than you, but you go ahead. We build them in a facility in Boston. They populate our boards, they assemble our devices, and they do the final provisioning. And we only trust overseas suppliers with like non-sensitive components like CNC machining and stuff. So the intention of this device is for your long-term, your bulletproof cold storage. And this still exists alongside Passport Prime. And then the new toy, Passport Primes, here's one of them. So it's small. This is a slightly different kind of device, capable of being your everyday carry, the digital equivalent of your wallet of cards and IDs, or a Swiss Army knife. So this is a security platform beyond just a hardware wallet. And what I mean by that is it's an app-based architecture. So developers, hopefully like you guys one day, can write their own custom apps for it and ship those directly to your users without needing our approval or permission, serve whatever purpose that you think the market needs. And think beyond just wallets for other chains. As standard, we're shipping with, yes, a Bitcoin signer, but also 2FA code stuff and YubiKey stuff and things. So you can do a lot more than just sign for coin stuff. On this device, we've moved to a modern touchscreen display. We have added Bluetooth, but with a quantum-resistant encryption. And we're going to talk about that in detail later on. We also have NFC, both read and write. Prime is not an Android thing or whatever. It runs our own OS developed from the ground up for security with flexibility at the same time. We'll talk about that in a minute as well. Of course, everything is still open source all the way down, although you might need to make some upgrades to your garage fab if you wanted to try and manufacture these things, but you can if you want to. And it's always still built in the US. We won't compromise on either of those two principles. They're very core to the business. So the envisioned use here is as part of your everyday gear, making the most of all the flexibility and the connectivity stuff. But of course, it's still an excellent modern hardware wallet that you could keep in your drawer and just sign Bitcoin stuff with if that's all you wanted to do. So that was a bunch of stuff. Let's reframe that in the context of being a developer. This means you can build something pretty much like you build a mobile app, with nice UI and familiar languages and stuff. But That can involve hardware wallet-grade cryptography. You are off in a distinct segregated device, not on their phone, with the associated security assurances that you get from that. But you could also reach the internet from it, even if you really wanted to. And you can add more security to that link if you wish, but other apps aren't able to interfere with yours, regardless. You have a bunch of hardware toys to play with on there, however you want, and you don't need to beg permission. Just go and make whatever you want. It's not our business. Oops. One thing you do have to beg for, though, is the SDK, which is still 6 to 12 months out, as we focus on shipping the actual damn device, which is a couple of weeks away. So we're here for a hackathon, and I'm not suggesting that you'll develop anything for Prime here this weekend, although you're welcome to if you want to. But I hope you might get some inspiration for the future, the next year or so. I am going to throw you a couple of prompts as we get through things to get the gears turning in your head. So it used to be that when you're doing something beyond basic payment signing, you had to choose. You can have either cold key security, or you can have seamless, fast, user-friendly UX stuff, but you can't have both at the same time. Are there any use cases that get a lot more interesting when you don't have to make that choice anymore? Two obvious ones are Lightning and Nostr. Keep the keys off the phone, but the user doesn't even notice, so long as the Prime is in their pocket. You're over Bluetooth. It can be locked in your pocket, and you can just be signing stuff on your phone, but actually the keys are off in a separate device. Or you could even add conditions to signing. Check out Validating Lightning Signer project. That's a perfect fit for Prime. Or use Prime as a personal policy signer. Ryan was talking about that this morning with, well, maybe not quite the same way, but like at a personal level. You could have the policy configuration stuff gated behind, like you have to present a special NFC card to the device to even get to the settings or something. Or your phone GPS might need to be in a specific geofenced area before you're allowed to access those settings. You know, you can get really creative with this stuff. Maybe you have to be plugged into a special dock. Everything from the talk this morning is applicable, roughly speaking, but maybe with slightly different utility because it's also you holding the policy signer. It's not some other place, some server somewhere. So there's some stuff to chew on for now. Let's get into the weeds a little bit more. So I'm going to walk through some key points in the architecture from like an app point of view and how this is going to work. Okay, so you've unboxed your new Passport Prime. Hooray. Generate a new master seed, or import one if you really insist. We're going to strongly advise you don't import one because then we can't protect you quite as well, but if you want to, you can. And then we walk through users through setting up 2 or 3 Shamir backup scheme. 2 shares go onto NFC cards that are included in the box, and then 1 goes to iCloud or Google Drive via our Envoy app on their phone, or they could do that 3rd share on another NFC card if they want. With this default NFC solution, we don't have to worry about them like storing a photo of their seed words on the cloud or anything. You just tell them, okay, keep these 2 physical objects in safe places. That's it, you're done. So with the seed and its backup handled, let's start talking about some app stuff. So each app runs in a hardware-enforced sandbox. I need to hide these, but remember that. And you can request dedicated hardened child seeds from KeyOS, derived from the device's master seed. Your app seed is unique to you. Nothing is ever allowed access back to the master seed. We then store those seed derivation powers issued to each app as metadata. Then we encrypt that metadata with the device master seed. And then we back that up on Foundation's cloud, if you want to, privately identified only by a hash derived from the seed, because we don't want to know who you are. And then your app that you develop will probably have some data that you want to store on the internal drive. You can use your app seed to encrypt that data. Then we encrypt the whole drive with the master seed too. And then as a premium service, we can also cloud back up the whole device drive to the cloud, again, encrypted by the master seed and ID'd by that hash. And with everything I've just mentioned, this is all just the default flows of things. Advanced users are welcome to do like whatever weird roll your own scheme you come up with. But we need to make this approachable for mainstream people. So to reinforce all that, let's walk through disaster recovery. Let's say you've thrown your Prime into the ocean like we were just talking about in the last talk. So long as you have at least 2 of these backup shares left, you're absolutely fine. Maybe you lost one of the NFC cards, but as long as you didn't lose 2 shares, you're fine. And one of those shares is in Apple or Google's cloud, which generally has like recovery procedures and things built in already. So you go and buy yourself a new Passport Prime. You bring those backup shares together inside Prime, and now your master seed is back, and that's it from a user perspective. You are completely done. Everything from here is all automatic. The master seed is used to derive your private ID again and request your encrypted data blobs from Foundation's cloud. And then once they're downloaded, your data gets decrypted with the master seed. The derivation path lets us reinstate the app seeds. Your app seed lets you recover its data from within the drive. So as an app developer, you don't need to worry about like any backup process at all anymore. You don't have to check your users like backed up their seed, or that you need to check what's word for before I let you move through the process or anything like. You don't care about that. You don't need to teach them how to secure it. You don't need to worry about like teaching them risk management stuff or hot wallets too much. None of that stuff. You know that because they're using one of these devices, it just handles all the backup stuff for them. So this is really good for normies. I hate using the word normies, but yes, normies. Okay, so another idea. What if you were to deliberately encrypt some data to something besides the obvious, like a key that's different to your own one? Could that be useful for like inheritance stuff somehow, or to give to your heirs or the lawyer or something? What about specifying a physical card that must be read in for that third party to fully decrypt stuff? So like maybe you give your lawyer the key to decrypt a share that you've given to your, you get the idea. Last bit of technical background stuff here. Quantum Link is how we can now offer Bluetooth connectivity in a way that meets our security principles. So we wanted the security of an air gap combined with the freedom of like wireless communication stuff that we're all used to now. We worked with Blockchain Commons to design a new protocol that would solve this problem. It's an open standard, obviously, of course, always. And the easiest way to explain this is to walk you through the pairing process. So Prime derives itself a key pair internally using a quantum-resistant algorithm, which is in a document somewhere that you can find later on if you want to, and shows the pub key of that as a QR code. The phone app scans it, in this case our app, Envoy, and using QR codes for this means that the Bluetooth chip never sees that key. With that pub key, Envoy now knows how to encrypt data for Prime and can safely send its own encrypted pub key back over Quantum Link, and that sets up a tunnel. And we use AES 256 for the messages themselves. That means we don't trust the Bluetooth chip. Messages are encrypted before even leaving the processor, well before the Bluetooth chip. So a malicious Bluetooth chip can't modify or leak your messages or anything. It's just in complete gibberish the whole time. And then the result is this secure communication tunnel directly between the apps themselves on the devices, giving security levels on par with the air-gapped, but with the flexibility and interactivity of Bluetooth. And this is all like so mainstream and easy, like the user has no clue what's going on with any of this. It just works by magic. And then don't miss something that's unique here. The tunnels are between the apps. This is not like universal access into the device to ferret around and do whatever you want in there. Only your app can decrypt the messages intended for it. And remember, all the apps are sandboxed from each other. So another key point, if you develop your own mobile app to go with the Prime app, that means that you're controlling both ends of the user experience. This is something that we make great use of with our products to streamline things for users, and something that previously only like hardware manufacturers could really do, because that's the other end of things, But now you can have it too as an app developer, because you can control what goes on in here, you can control what goes on the phone screen, you know exactly what's going on the whole time. If everything is open source, your users can trust you, etc., etc., etc. So that's the key technical architectures that make Prime like more interesting than your usual hardware wallet. Another thing to ponder, what possibilities are there if you added a pairing to someone else's device? Could you give them like limited access rights into something? Do some kind of like collaborative signing or decryption shenanigans or something? I don't know, what do you think? So now you have the background, let's look at some ideas for weird stuff that you could do with this platform and kind of not really anything else before. I am going to talk mostly about inscriptions and ordinals because that's what I understand the most, but I think you'll be able to abstract the concepts away for other things. We're all fundamentally doing stuff with moving sats in a specific way and like tagging bits of data into those in various ways ultimately. As I said, we will have an SDK and documentation, but it's about 6 to 12 months out whilst we focus on shipping the basic stuff on the device. So I'm only wanting to get you thinking here, really. I'm not expecting to be your hackathon project focus. Although if you did want to, you should know that you can use pretty much the full Rust library. And remember, it's lint for UI stuff. So if you wanted to play with something this weekend, you could do like the interesting cryptographic mechanisms and think about the hardware segregation stuff and just put placeholders for the OS specific stuff. Send message to Prime, send message to phone. Okay. Using metaprotocols with hardware wallets is not really straightforward. The user wants to send their non-Bitcoin asset, and it might be very valuable. But at least in Bitcoin, assets are all handled by metaprotocols, the second layer systems that just interpret the blockchain data in a different way. And none of our industry signing devices really know any of them at all. Bitcoin signers are only made for properly moving Satoshis, including our pre-installed Bitcoin app. And the metaprotocol may or may not align intuitively with the UTXO model. You could easily send SAT successfully, you screw up the metaprotocol stuff and just burn all that stuff. The most common industry practice seems to be browser extension wallets with websites and magical buttons and pop-up pages. At the very best, you might get ledger integration, and that's like a teeny tiny screen, and there's no clue what's going on with the metaprotocol stuff. So in an ideal world, surely you would have the user review the metaprotocol transaction, send 50 USDT from here to here, on the Prime screen, their hardware wallet screen, where everything can be trusted, and actually hide away most of the Satoshi stuff, right? So how do you go about doing that in reality? Is it legit to go and ask some other metaprotocol node or indexer to tell you the state of things? Are you trusting them entirely? That could be on your phone. Maybe it could be in your phone app that you as a developer make. And as we said, you can easily send the Bitcoin successfully. The transaction gets mined, but you've burned the metaprotocol asset. If you can't do that, is it feasible for Prime to know the metaprotocol state for itself? Can you do it still outsourced a little bit, but in a trustless way? This is like sort of a solved problem with Bitcoin itself, but on higher layers, we don't have the luxury of an invalid transfer not getting mined. It can make it through, but still fail in the metaprotocol perspective. And how much validation could you do on a Prime? Does it have to be stripped back to make it practical to run on this device? I mean, it looks like a phone and it's very competent, but it is a small device built for security things. It's not a laptop. I'm thinking at the very least like ordinals first in, first out accounting and visualizing the stats flow like MempoolSpace does maybe. That would be like useful and straightforward, I think. Maybe you like add a trace line for the first sat in each input and output, since that's probably the important ones, so the user can at least follow visually what went from where to where, from UTXO to UTXO. And maybe you add like a tap on an input, it would open up an explorer, and that lists what's inscribed on the sats inside, although that means you're trusting people, so start thinking about this stuff. Next thing. A signing device with the hardware to actually show an inscription is pretty rare, so we should definitely do that because it's definitely cool. But you can't pass it out of the transaction PSBT that we're handing to the device, because as we just covered, you need to pull metaprotocol info from somewhere. In this case, you need to query a full node for the inscribed data. You're only actually signing to move like one SAT. You should definitely be doing the inscription rendering on the device, because if you cheat and do too much on the phone, there's no point. That's not fun. But this is going to have limitations because they could theoretically be like massively recursive, and when we're a security device, we're not a PC. So how much is reasonable to do? Do you have to implement like a whole web browser thing, canvas thing to run on here, since they can be almost any web content format? Do you need to filter certain file types to not show them on here because it's just too risky, seeing as you're near keys? I mean, theoretically, the OS design protects you from that stuff, but PDFs, for example, stuff to think about. And then if we went even further than that, if you saw Quantum Cats last year, handwork of our very own Rindell, who's the regular suspect in these talks, they were built around the concept of inscribing encrypted layers of artwork, which would only get revealed later on when the decrypt key is inscribed and therefore can be found on chain. I think inscriptions can reference data about their owning Satoshi and their address. So now you have the flexibility of designing an app, can you make something with a layer that's only decryptable by the device that holds the keys for the current owning address? And you could use that for something like an authenticity stamp maybe, or like a secret message from the artist to the owners, never readable by observers on chain or anything. What if this layer wasn't a dumb graphic, but unlocked like recursive references to other inscriptions? What if you also had to read in a specific physical NFC card to fully reveal something? What about if it wasn't even a graphic at all, but like some other data, like for what? There's interesting things to play with in here. And then the last thought, so during the NFT craze, people were really big on using them as like access credentials to exclusive clubs and parties and so on, and that was fun to a lot of people. What if they literally were physical access credentials to open NFC door locks? So using that encrypted layer principle from the last slide, I think that would mean it would be a one-way thing, since once someone can decrypt the code, they can save that and they can always access it the same way. But maybe that's actually cool. Maybe that's fun because it's like only previous holders of this thing can ever open this physical door. Or maybe there's more things that you guys can think of. And so closing thought, there's something about doing things on Bitcoin that makes them feel more concrete and tangible than doing things on other chains. And I think any kind of physicality makes things so much more engaging and fun. And we all like live in software world all the time here, but you don't have to. There's physical stuff you can play with. And I think there's a lot of possibilities there. So that's the end of my brain dump. I hope I've given you guys some stuff to chew on. Thanks very much, and then maybe you have some questions. Oh no. The back row, these guys have all the questions. This is going to be tough. Be gentle with me, I'm a hardware guy.
Hey, I'm going to start it off, first time asker over here. One of your earlier slides, I actually have a question not to do with the interesting thing. I'm actually curious about the hardware device that you had like a little side note that says your device or ours for, I guess, like network access. Yeah, right here. Yep. And I was wondering, what does that mean when you say ours? Oh. Because I understand pairing with my phone and then, hey, now I have access or whatever. What do you mean when you say ours?
What I mean is that, so we're selling a device, yes, but it has a companion app for a mobile app. And users are using that right now. It exists for the existing product. They're using that to build transactions and do basic wallet stuff. But what I'm saying is that your device doesn't have to pair with our app. You can make your own app for the phone and do whatever the hell you want with that stuff.
Okay, got it. So when you said reach the internet, I thought we're talking specifically for some reason. Okay, anyways, and then you're kind of going from like a Nokia phone to like a smartphone. I mean, you're more and more it's looking like a normal phone. Do you think it will have more access to interface with other devices and maybe have its own independent network connection in the future, or do you think you're going to
I think that's probably too risky. So one of the things that's nice actually about being a hardware manufacturer is that there's a natural moat to this, because like a phone could do everything that this thing can do, but there are things where it's nice to have it be in a separate, segregated physical thing. Like I know whatever's going on in here is not going to be leaked to the cloud, or there's some other app that's not like snooping on it, that's Flappy Bird or something is not actually looking at whatever's going on inside my phone app. So we probably won't get much more connected than Prime is going to be, because you get all the benefits of being basically a phone, but you can still provide some degree of like security by the architecture. Does that answer your question?
Yeah, I've been seeing this like butt to mouth frost thing that's been going on. These devices that can communicate with each other, and I was wondering if there's any appetite there for y'all maybe to have some PSBT type stuff, or something done between the devices even.
But you could totally do that. You can do that right now. You don't.
But I thought they're all talking through a paired device.
What he's saying is I'm not sure I fully understand. I'm not sure I fully understand. So okay, I understand the Frost Signer thing. Those are cool, but like a bit niche. You could build an app that does that exact same functionality if you wanted to on this. We have talked about, is there anything fun if we let this talk to those exact devices? And the answer so far has been like kind of not really, although it would be fun to just hook them up together, but it doesn't really do anything that practically useful. But there's no reason you can't. This is a USB-C port in it, so you can do whatever the hell you want with that. Maybe you come up with something. I don't know. That's the point. You have a platform now. Make whatever you want. Try it.
So this is a really half-baked idea, but on your third Nerdsnipe idea where you were saying, inscribe something that's like encrypted to a specific user, and that would make sense for like door access code, right? Like I don't want to inscribe that as a public inscription and have everybody be able to open the door. I want to make sure that, I inscribe it to Alice and she's allowed to open the door and like nobody else, right? So if somebody wants to explore this, a thing that might be interesting is if you look at like how silent payments work, right? When I send a silent payment, I take my private key and then your public key, and I do Diffie-Hellman, like a lifted curve Diffie-Hellman, to come up with like a shared new address, and that's what I send it to. You could use that to make a encryption key that then you encrypt the data with. And what's cool is because the private key material is only available on the new passport, I could like make an inscription where the only person other than me that can decrypt the data is the device, because it's able to like derive this symmetric encryption key that then you go and use to decrypt the data. So if you know, what this would look like is like I encrypt this, I inscribe this encrypted blob and I send it to an address. That address is like owned by the passport, and then the passport is able to decrypt it. And like maybe what you'd really want to do is pass the inscription blob like into the device, and then have the device like decrypt it for you and do whatever. So if anybody's interested in this, like maybe look at what Silent Payments does.
That's a really cool addition. I didn't think of that. That makes a lot of sense.
I have a very like practical question. Is like you mentioned you have your own OS and then you create your apps. How do you go about doing that? Like, so when I do Android stuff or Apple, I use Android Studio or Xcode or whatever the Apple thing is. Is there a way to like simulate the foundation device such that I can create an app without having the device? I mean, you haven't shipped them as well, so that's kind of the.
I know that our developers have that, and I imagine that we'll be releasing that at some point. So not right now. There's nothing for you to play with publicly right now, but I'm sure that there is something like that.
Okay, and then you said it's all written in Rust, so okay, I like that.
To the best of my knowledge, I'm a hardware guy.
Oh yeah,
as I understand
know.
it, yeah.
Yeah, thank you.
Can you talk a little bit about how people auth into the device? I presume that there isn't any kind of biometric that you could use
Oh,
to
right.
go,
Okay.
to go in
So,
faster.
you know, you pick up mine. What stops you from logging into it? So we encourage them to set up a at least six-digit PIN first. And as I understand it, I think that encrypts everything inside it. But we also let you do like as many characters as you want, alphanumeric, if you want to as well. So you can have like as convoluted a password as you possibly want. But that's your basic sort of security. So there's no like fingerprint or biometric stuff. There is an ambient light sensor if you wanted to play with that in there. That was useful in some way. We use it just for screen dimming, but that's in the hardware too. Forgot about that.
So you're using an STM32H. Can you talk a little bit about your choice of secure element and kind of what hoops you had to jump through to use it? What is the open secure element these days? And
I cannot talk about that. That is way out of my wheelhouse. I know that whatever secure element we use was in here somewhere, the 802C or something, I think I put somewhere. That's the extent of my knowledge on it, I'm afraid. What's it in here? Yeah. Were you alluding to the Tropic Square secure element?
Not really alluding, just very curious. Whenever someone chooses a secure element, it's like a very important moment in the design of your device.
I would direct you to speak to our CTO Ken, who could talk all about that, and he would probably be thrilled.
I'd love to. Thanks.
I work on CNC machining and like making it look pretty.
What's the spec of the resolution of the display and color depth?
Good question. I don't know that off the top of my head.
All right.
You're welcome to look.
No
if you
problem.
want.
Well, just, you could do something pretty interesting looking maybe, if it's good enough. The other thing is, and maybe this is on your website, but what's the cost per unit?
Oh, $299.
$299, and at volume maybe, say 3,000 units.
I don't know. We do have like a distributor arrangements like in Europe and things, so maybe you'd be interested in talking to them about doing something like that.
Okay.
I don't know about that part myself.
Any other questions? Okay, thank you.
Okay, thanks.